Hi, Thomas. I don't know if you can hear me. If you can hear me, chat me, or you can switch on your mic. Switch on your mic so that we can probably converse if you can hear me. Otherwise, do me a chat so that I know we are together before we start.
Hello. Hello.
Thomas, I can hear you, eh? Otieno.
Hello.
Yes, Thomas.
I'm listening.
You can hear me, eh? Thomas. Okay, seems like there's a problem with your mic, eh? Now you can hear me.
I
Umekula lunch?
nishakula lunch.
Umeshakula? You're in Kisumu City or you're in Nairobi?
I'm in Nairobi.
Oh. Now it seems like you're the only person online. I don't know where these other guys are.
Wameenda kutafuta lunch, I guess.
Did you have another class before this?
Yes.
Sasa ikaisha at exactly 2.
Ilisha 12:30.
They had enough time to go for lunch. So what do we do?
Maybe we look for them.
Have you gone through the notes I shared? Pardon?
Maybe we wait for them, give them an allowance of 10 minutes.
Okay. In the meantime, my question was, have you gone through the topic 1 notes that I shared with you?
Not yet.
So even if I'll be doing a recap, I'll still be like introducing something new to you.
Actually, don't enroll to class size.
Oh. Okay, we'll see if you'll still be the only one online after the 10 minutes we've agreed. I'll just take you through the recap of chapter 1. Then, if time allows, we can discuss something small on topic 2, because topic 2 is a bit broader. So we'll recap chapter 1, then do something brief on chapter 2. Seems sawa, Thomas?
Sawa.
Aya, let's give them the 10 minutes.
Nikizima nitatoka nini? Nitatoka.
Nice. Ombe hapa 30 minutes. Sasa pengine kuna mtu darasani, mwingine alienda kuona demu yake amechelewa kurudi. Mwingine sijui alikuwa
Thomas, mute your mic, eh?
Nitafuta watu wengine.
Sasa unaweza imagine Zoom, moja yako na wewe anakuuliza swali, unajibu kumpatia. Na sasa yeye anangojea wewe ndio umpatie. Ni live unaona. Basi unaweza ukaswitch umuone na unaweza ukatoa pia usimuone.
Yaani ni ameka tu audio peke yake.
Yes, when you're on. So this person is really no. I so far. Kama jana tu mapsi ya kesho. Ndio watu maswali au ndio wanajibu juu. Mimi najifanya mimi yani sijui ama mimi najifanya niko na hiyo content But sasa nauliza question. No, I saw in the notes there was somebody please explain. Sasa hiyo ndio nasoma jana. Unaweza imagine umekaa tu chini unasoma topic one note. Yes. Subscribe and you share and like.
Mamas, we are back, eh? We cannot wait for these people forever. I think the best we can do is just to carry on to save on time, eh? So I think we can do our recap on chapter 1, which is basically an introduction into the concepts of what a computer is, of which I've given you some 2 major definitions of what a computer is. In the first definition, you're saying that it is an electronic machine. I hope you can be able to see the presentation, the display. Okay. I hope you can see what I'm displaying. So in the first definition, you're saying that it is an electronic machine that accepts information, stores it until the information is needed, processes the information according to the instructions provided by the user, and finally returns the results to the user. So that's how we can broadly define what a computer is. But take note that we are saying it is an electronic machine. That is one major underlying aspect of what a computer is. It is an electronic machine. Then we are saying it accepts, which simply means that it allows users to interact. It allows users to be able to key in data. And we cannot say that a computer can process information if there is no input, if a user has not keyed in anything. So it must first allow a user to access information. It must allow a user to key in information. Then the information can be stored if there is need to store it. It can store information if there is need to store it. The reason we are saying it can store information is that at a particular time, you might find that if a computer is to process something, the CPU might be busy at that particular time. Okay, it might be busy. So whatever input that is interacted into the computer will need to be held somewhere as it awaits for the CPU to become available. And that's why we're saying that it stores it until the information is needed. Then we are saying it processes the information, which basically involves manipulating whatever input it has received from a user into something that can be used for decision making. Because at the end of the day, when we use these computer systems, we're using them to make our work easier. We want to make decisions here and there. We want to perform certain tasks here and there, etc., etc. So whatever has been keyed in must be processed into something that is meaningful. Then we are saying the results can then be given back to the user. Okay. The number 2, we are defining it as a programmable multi-use machine that does what we've already talked about. It inputs data, processes, stores, and outputs. So why are we calling it a programmable system or a programmable machine? We are saying it is programmable because a computer system cannot work on its own. It cannot think. If you want to type a document, for instance, the computer system cannot on its own type that document that you want. But there must be an application, there must be a program to guide it to type that document that you want. At the same time, a computer system cannot run on its own. Whatever it wants to do, maybe to process something, it cannot do that task without the guidance of a program. So when you talk of programs, we shall look at that later when we'll be talking about the components of a computer. So the computer must run through the guidance of programs. The most basic one, or maybe the most important one, being the operating system. So if you do not have the operating system in your machine, there is nothing that computer can do. So we are saying that it is a programmable multi-use machine. Multi-use to mean that it can be used for so many tasks. Although there are some computer systems that probably are designed for a particular task, maybe to do a specific task. For instance, something like what do you call it? A calculator that you use to do your mathematical calculations here and there. There is nothing much you can do with that calculator apart from just doing the mathematical calculations. So that is designed for a specific use. But generally, computers can do so many things. They can allow you to store, they can allow you to communicate, they can allow you maybe make documents or maybe prepare documents. So do so many things. Okay. So we are calling it a multi-use machine. Okay. So that's how we can define what a computer is from the two perspectives. You'll go through the notes, you'll be able to learn more about those definitions. Then we have 4 major tasks that a computer can perform. That is input, storage, processing, and output. We've talked about this already, so I don't need to go through that again, because you're just doing a recap. So you're just like brushing through. Dixon, we can hear you. You can mute your mic. Dixon, don't mute your mic so that we avoid making noise for the rest. Okay. So I think that's it with the definition and the tasks. Then we have classification of computers. Why is it important for us to understand classification of computers? When you're talking of the organization of a computer, normally we might say that all computers perform the 4 major tasks that we've talked about. All computers perform the 4 major tasks: input, processing, storage, and output. But when it comes to the nature of these computers, they have different features, or we can say they exist in different formats. They exist in different sizes. So we cannot, for example, categorize a mobile phone and something like a web server as computers belonging to the same level, or maybe computers being at the same level. They are both computers able to do the 4 main tasks, but existing at different levels or having different features. And that's why we are saying that computers can always be classified. And normally they can be classified into 3 main classes. We have classification according to size, we have classification according to the purpose, and we have classification according to the technology that has been used to design those computers. So number 1, according to size, classification according to size. We're saying that computers can be classified according to the number of elements that they integrate. According to the number of elements that they integrate. For example, if we talk of, maybe I can still use that example, a cellular phone, a mobile phone, and a web server. A mobile phone is very small, and that's why we normally call them personal computers. They're very small, or maybe we can call them microcomputers. But if you look at a web server, it is at a higher level because it is integrating more components. It has a higher storage capacity. It can maybe support multiple users. It can be able to process very fast. So there is more that is brought into, or maybe is integrated into that computer system. So when you say that computers can be classified according to size, this is determined by the number of elements that are integrated in those computer systems. So under that class, we have supercomputers, which are at the highest level, followed by what we call the mainframe computers. Followed by what we call the mid-range computers, or maybe we can call them the mini computers. Then at the lowest level, we have what we call the microcomputers. So the microcomputers are what I was referring to as personal computers. They're very small. Talk of something like a laptop, talk of a desktop computer, talk of your cellular phone, talk of that calculator. These are very small computers because they do not integrate so many components in them. They are meant for single use, or they are meant to support a fewer number of users. So if we can compare, sorry for that. So if I can compare a microcomputer and a supercomputer, you'll go through the notes. A supercomputer being at the highest level within the same class is very big. A supercomputer is normally very big. So if I can compare a microcomputer to a supercomputer, there is no way you can ever see somebody walking around with a supercomputer, because it is something that needs to be stationed somewhere in a room, and it normally occupies a bigger space compared to a microcomputer. A microcomputer, you can have one in your pocket, you can have one in your bag, and you walk comfortably. But supercomputers, since they integrate so much, they are big or they are large, and they're also very sophisticated, and they do quite a lot as compared to microcomputers. Yeah? Then you also have the mainframe computers. Mainframe computers, they're also big, but not as big as the supercomputers. They also integrate so much, but not as much as supercomputers. Then we have the mini computers. These are the web servers that are used to control computers in a network and all that, or maybe to be used as database servers in institutions and all that. So at the same time, they must be able to support as many people as possible, but not as many as what supercomputers can support. So we have classification according to size, which involves all those 4 categories. So that is class number 1, classification according to size. Then number 2, we have classification according to purpose. Let me display that for us. When it comes to classification according to purpose, we are looking at what computers are designed for. So we cannot expect that computers are designed for the same purpose. Like I had given that example of a calculator. A calculator can only be used for performing mathematical calculations. So computers can be classified according to what they are designed to do. So we have these 2 categories: general purpose computers and special purpose computers. So for general purpose computers, these are what we are used to: the laptops, the desktops, etc. So they can do as much as we want. They can allow us connect to the internet. They can allow us store some files. They can allow us create documents. They can allow us create presentations. Name them. So they can be used for as many tasks as possible. So we can categorize a computer as a general purpose computer. At the same time, we can calculate. We can categorize another computer as a special purpose computer because it is designed for a specific task. Think of something like the traffic light system. How much can you use that traffic light system for? There's nothing much you can do with it, or there's nothing much that it can help you do apart from just telling you, it's time for you to move, time for you to be ready, time for you to stop, and blah blah blah. There's nothing much it can enable you to do with it. So we can say that that's a special purpose computer. It is designed specifically to control movement of people and vehicles on the road. That calculator I'm talking about, it cannot allow you to do anything much. Like I said, it can only allow you to perform mathematical calculations. So it is only designed for that purpose, to allow you perform calculations and calculations only, nothing much. So we can say that those are special purpose computers. Okay. Then the last category is what you're referring to as classification according to technology, where we have analog computers, we have digital computers, and hybrid computers. So according to technology, we are looking at the nature of activities that take place within these computer systems. So if a computer system is able to process data as a continuous measurement of a physical property, we are saying that we can categorize that as an analog computer system, although currently we do not have so many of them being designed, because the focus currently is on digital computers. But you might find there are some people, or maybe there are some areas that might still need to use analog computers. So if computers are designed based on those characteristics, it can best, or maybe they can best be categorized under analog computers. So the reason I am saying that it processes data as a continuous measurement of a physical property is simply that when an analog computer receives an input, that input goes directly to processing. It doesn't store before processing is done. So as it receives an input, that input goes directly to processing and an output is given. I've given that example of an automobile speedometer, a speedometer in a vehicle. So what happens with that speedometer is that as speed increases, it tells you that this is the current speed that the vehicle is moving at. As it increases or as it goes down, it gives you that information instantly. Okay? So it processes information as it comes in. There are actually no stages of processing information. So information goes direct to processing, output is given. And if I can compare this to digital, for digital, we say that it processes discrete. It processes a discrete signal. A discrete signal simply implies that that signal has some highs and lows. It is not like a straight line. It's not like continuous like analog. It has highs and lows. So at the end of the day, a digital computer will have to interact input first. Before it processes that input, it must convert it into highs and lows. So the input must first be converted into a digital format that involves representing it in form of ones and and zeros. So that's what happens to digital computers. For hybrid computers, they process both analog and digital signals. But the question that probably we might be asking ourselves is that why then are digital computers probably faster than analog computers? Maybe I can pose that question to you. Why do you think digital computers are faster than analog computers? Yet digital computers have to first of all interpret an input before it is processed, or digital computers have to translate an input into binary, that is ones and zeros, before that input is processed. But analog process input directly. It doesn't need to convert anything. Maybe you can switch on your mics and share your ideas if you can hear me. Why are digital computers faster than analog? Yet they need to convert an input into a digital format before it is processed. Or you can chat. We have Cleophas, we have Dixon, we have Jalimo, Roy, Thomas, and Wanjiku. Let me get your views. Let me get your answers. Share your responses via the chat.
Let me show you.
I'm waiting for your responses. Let me know if you are together.
I'm trying. Can you hear me? Hello? Hello? Hello?
Yes, please. Cleophas.
Yes, I'm trying.
Cleophas. Yes, Cleophas.
I think it's because digital computers.
Because?
Digital
Pardon?
computers are discrete.
Mm-hmm.
That's what I think.
Because they use discrete signal, or maybe they process. We can refer to it as they process discrete signals.
Yeah.
So they process discrete signal, which is a combination of highs and lows.
Yeah.
But then the question is if a digital computer has to first convert a signal, I mean an input, into a discrete format before it processes it, why is it then that it takes a shorter time as compared to analog, which does not do that? Because for analog, it doesn't convert a signal into anything. When it receives an input, it automatically processes it. So why is it that digital computers are faster than analog?
In that case, I don't know.
Hapa imekuwa ngumu.
Hapo imekuwa ngumu.
Let's wait and see what these other people have to say.
Okay.
I'm talking of Cleophas, not Cleophas, you've given your idea, Ndungu, Dixon, Jalimo, Roy, Thomas, and Wanjiku. I'm waiting for your responses. Okay, Dixon is saying that because the technology and the processors that they use are made to process faster. It might be one case, or you can say yes and no. Let me say yes and no. Another trial. Another trial. Okay, maybe I can respond to that question. The reason we have, or maybe the reasons why digital computers process faster than analog, despite the fact that they have to convert an input signal into a discrete format, is because when the processor has received this signal that has already been interpreted, it has already been converted into ones and zeros. It is like that signal has already been chewed for it. It has already been interpreted. We shall look at components of the CPU later. We'll get to learn more about what normally happens within the CPU. So for digital computers, when it comes to processing is faster because whatever is taken into the CPU for processing has already been interpreted. It has been presented in a simple format, in the simplest format possible. But when it comes to analog, remember for analog we've said that the signal is continuous. So as input comes in, it goes directly to processing. There's no interpretation anywhere. There's no conversion anywhere. So for analog, they end up processing complex signals. It's like you're giving a small child a solid food to chew. It means that kid will take so much time to chew that food because that food is not smooth. It is kind of hard. So the kid will have to take time to chew it before swallowing it. That's what happens to analog. They take time to process because they must first understand what they have received, then go ahead and process. But for digital computers, whatever has been received for processing has already been interpreted. It has already been chewed for them. So it is soft. And that's where the aspect of it being faster comes in. Okay? So that's what happens. Okay. So unless somebody's got any question to that, we have lost our power, so I might go off air in a few minutes. Unless somebody else has got any question. Any question from any of us? You can use your mics. Any question? So if there are no questions, I would allow you to go through the notes on topic 1. And in case there will be any queries, you can always let me know. I don't know how much I have covered in chapter 1. We have classification of computers. Classification of computers. Seems like power has distracted everything when the network. I think that's the last slide. Slide number 6. So just go through what I've provided in chapter 1. In case there will be any queries, when you meet next time, you can always communicate. Now, going to chapter 2. I'll not be able to display chapter 2, but I'll just, I think I shared everything in the portal. So chapter 2 is basically the components. We want to further understand what this computer system is made of. So we want to understand the components of a computer system. And I've presented as much details as possible. But just to give an overview, when it comes to these components of a computer, we can always categorize them into 2 broad categories. There could be other categories like the liveware. But remember, for our case, for this unit, maybe to make the point clear, we're interested at looking at a standalone computer system. It's like that probably desktop that you're using. You want to understand it. You want to understand that tablet that you're using. You want to understand that a cellular device that you're using. Interested in a standalone computer, how it is organized. So we're not going to the aspects of networking. And that's why we only focused on the 4 basic tasks: input, processing, storage, and output. We did not look at communication, which involves networking, because we're not interested in networking. So when it comes to the components of a computer system, we're only interested in hardware and software. But we'll give more weight to the hardware, because when you talk of computer organization, we are like looking at the layout. How is a computer system laid out for it to be able to do what it does at the end of the day? For us to be able to receive a display, for us to be able to store something, how is this computer system organized? Okay, I know probably when you're doing introduction to computers, you looked at maybe the components here and there, but you did not go into the details. Maybe you were told that there is the CPU that does this and this, but you did not open up the CPU. So for our case, we want to understand the structure of that CPU. We want to like open it up. So when you talk of the components, we'll only focus more on the hardware components and software components, but we'll give more weight, like I said, to the hardware components. Okay. So basically, when you talk of the components of a computer system, we can say that they are categorized into 2 broad classes. That is hardware components and software components. The hardware components being the tangible, the physical parts of a computer system. And for the hardware, we shall focus on the CPU. We shall look at storage. We shall look at what else? The motherboard. I think that's what we'll focus on more. Storage, and for storage, you shall look at magnetic storage and optical storage. Then for the CPU, we shall get to understand what makes up the CPU. For the motherboard, we'll only touch on what is covered on the motherboard. For the software, we shall look at the 3 different categories of software that are available or maybe can be implemented or can be used in a computer system. That is the application softwares, the utility softwares, and the operating system. And again, we'll give more weight to the operating system. For the application softwares, probably we can read on our own. For utilities, I can touch here and there, but we want to give more weight to the operating system being the major software for any given computer system. Okay. So maybe you can go through the notes. My laptop is going down in a few minutes. Unfortunately, I would have wished we cover more, but you can go through the notes on topic 2. I've given you the learning activities. Attempt those learning activities. In case you experience challenges, let me know. The same case for topic 1. Attempt those activities I've provided, and where necessary, give feedback. Then if all goes well, when you meet next week, we shall do a recap of chapter 2. Unless somebody has got a parting shot or maybe something to share with us before we go down, or before personally I go down. Anybody? You can now switch on your mics. Switch on your mics so that I can hear your voices in case you have something to share. Cleophas, Jolima, Roy, Thomas, Wanjiku, do you have anything that you want to share before my laptop goes down?
Hello.
Yes, Jolimo.
I want to ask, is the learning activity must be submitted?
Yes, it should. We have indicated. For example, if I've said it is an essay, submit it. I think I need to give you the timelines for submission. I've not been giving you timelines. I've just been leaving them open. But where we have said you write an essay, or maybe you do a comparison of some 2 aspects, give me that feedback. Unless I've told you to read. For reading tasks, that's why I do not expect any. I do not expect any feedback. But for all the other tasks, I expect some feedback. For discussions, I would want to see you discussing. I'll give you discussions later. Any other question? I'm at 7%. Cleophas, any question?
Mine is not a question.
Mm-hmm.
Just a request. Some of us have never met you.
I've never?
I've never met you.
Mm-hmm.
We're wondering we can see your face so that at least.
Oh, you wanted to see? In fact, I was just about to do that, but I was a bit worried whether it is going to be possible because of the power issue.
Okay.
But I thought we had a class on, I mean, yesterday from 11.
No.
You were not there yesterday
There was a class yesterday.
for database design.
No, you said that.
For database design.
You said that you had a problem. You didn't make it.
Yesterday, I think we had a class with you guys from 11. Hakuna one of you that was there yesterday. I think I saw this Thomas. I think Dixon. You were not there yesterday.
I was online, but I don't think there was there was an online a live one.
There was a what?
Was there a live class yesterday?
I thought I had a live class yesterday with you guys.
No, you sent us a message.
Or what happened? Pardon?
I was online, but I didn't see the live one.
We are talking on a big blue button.
No, it wasn't present.
So you're saying you've never seen me?
Yes.
Can you see me now?
Yes,
Let's see.
You can see that face?
Familiar.
It's very familiar, eh?
Yes.
You've seen it somewhere on the corridors.
Yes.
Dixon, Roy, and Cleophas, you've seen that face, eh?
Yes.
Somewhere around campus.
Okay, so if my power is going down, I don't know what you're going to do. So I think we can meet next week. We can agree at that, eh?
Yes.
Yeah.
So raise your notes at chapter 2. In case there will be any questions, you will raise them next week, eh?
Okay.
Yeah,
So we'll meet on Monday for database and Tuesday for computer organization.
Okay.
Kuna mtu ako na shida ingine somewhere?
Okay, that's fine.
Anybody else having? Sawa, eh? So let's work on that. So you continue staying safe. We'll meet next week.